Now, this theoretical analysis is actually relevant. There's plenty of experimental evidence that in cases of common values, people often do the wrong thing. And here is a small data set from the early 70s of drilling an auction for drilling rights. And the details here aren't that important, except notice that the range of bids. Here are four different tracts, four different auctions, and notice that the bids range from 3 million to 30 million, from half a million to 40 million, from 6 to 43, again from half to 10. So obviously something's wrong in this scenario. Some people are vastly underestimating and or vastly overestimating the values of these. You can see the impact of winner's curse not only indirectly by the big divergence of the bids, as we saw in the previous slide, but in the outcomes of auctions. So these are different auctions for drilling rights offshore. This is data from, as you see, from the late 80s. And we will not go through the entire numbers here, but I'd just like to kind of point out a few things here and tell you how to read this. So here are all the bidders in the set of auctions. And there were multiple properties on which to bid, hundreds of those. And this column tells you how many bids each of these bidders put. So for example, Shell bid 426 times. This column tells you of those times, how many times did it win? And that's the number. Now, once they won, the question is, what do they do with the field? And in some cases, they go and inspect the area and decide upon closer inspection it's actually not worth trying to drill. And so this column tells you in how many of those did they even try to drill. And what this column tells you is that of all the drills they tried, how many of those actually struck oil. These last two columns are maybe just anecdotally interesting. Here we get to something that's economically directly meaningful. This tells you the difference between the value of the fields that the particular bidder won and their total bidding, pi and b1. So for example, Shell did very well. They have an excess of $500 million for all the oil fields they won. Compared, for example, to Texaco, that has lost $370 million. That is, the value of the fields that it ended up getting was $370 million less than what they paid. This, out of curiosity, says so. This simply divides by the total number of wins they had, and so $303 million is the average value for any field they won rights to. So in other words, it's 533 divided by 164. And this over here, also somewhat instructive quantity. This tells you, let's say they had won all their bids had won. How would they do? you would expect them to do better because typically the bids that won are the high bids, and including bids where they overestimated the value, whereas the low bids that lost, many of them underestimated the value. So had they won, then they would have won below the value and would have made a lot of money that way. So you'd expect these numbers to be higher, and they are. So you see, for example, that had Shell won all their bids, they would have made almost twice per field as they did. This last column here is also interesting. This tells you how much less should the bidder have bid overall across his bid to have been optimally off in this auction. So, for example, let's take Texaco, which, as we've seen, substantially overbid and lost on average over $8 million per winning, and even had it won all its bids, including its low bids, it still would have lost money. So obviously it should have bid less, and the question is how much less. And what this number tells us is that it should have been 85% less. It should have bid 0.15 of its actual bids. That would have been the optimal bidding for Shell here. So obviously, the lower the number, the bigger your winning curse has been. And we see that in some cases, such as Texaco's, the curse is in fact quite negative. So the general lesson about common value auctions, and in general when the values are affiliated, even if not perfectly identical, is that the strategy should consider what I will learn once I've won, and factor that into your bidding. And as a result, the equilibrium would be quite different than what the equilibrium would be in the private value setting. And many of the results we've seen for the private value setting no longer hold. The English auction, for example, is no longer equivalent to the second price auction, because in the second price auction, you get no information before you open the bid, where in the English auction, you do. Revenue equivalence no longer holds, and so on and so forth. So by now we've covered the material we want to cover on auctions in this introductory course. There is much more information about auctions, and while we won't speak about it in this part, let me give you a sense for some of it. First of all, there's the literature on so-called optimal auctions. We've seen the revenue equivalence theorem that holds for the private value setting, but what it tells you is that under certain conditions, in particular where the auction is efficient, it's always the case that the guy with the highest values for the item wins. You get revenue equivalence. But does that mean that you want to have economic efficiency? If you want to maximize your revenue, perhaps you should give up efficiency. And in fact, the answer is that you do. You do it by inserting a certain reserve price that says if nobody bids above it, I don't sell the item, or if you wish, I sell it to myself. And you risk having the highest guy not get it, but as a result, you actually get higher revenue. And there's an interesting analysis of what the reserve price should be to indeed maximize the revenue. Multiple unit auctions are interesting. So you have not just one camera, but many cameras for sale, and you are bidding not only a price, but a price and a quantity, or more generally what's called a schedule. You say for each price, this is how many I'd want. And there's interesting tweaks on the analysis based on that. Digital goods are another interesting case. Of course, digital goods are things like music and electronic books. And what characterizes those is that they can be duplicated for essentially zero marginal cost. And so essentially you have an infinite supply of those. You can view this as an extreme version of having multiple units of goods. Combinatorial auctions are very interesting. They are, again, a case where you have multiple goods, but not all identical. And so you have a market for left shoes and a market for right shoes. Well, what you really need is a pair of shoes. Getting one or the other is not useful for you. Or you have a market for Nikon and a market for Minolta. You only need one camera, so getting both of them is essentially as good as getting one of them. What you have there are what are called complementarities, that the example of the right shoe and the left shoe, or substitutabilities, and that's the example of the two cameras, and that makes for a very, very interesting set of challenges, both economic and computational. So far, we've considered one-sided auction where there's one seller and many buyers. You could imagine a reverse auction, in which you have one buyer and many sellers. This is sort of supply auction where people are getting a bid among the various suppliers. You would think that these are completely symmetrical with the other one-sided auction with one seller and many buyers, and for the most part they are, but there are some actually interesting distinctions. But then you have two-sided auctions where you have multiple sellers and multiple buyers, and that gets very interesting. And when you add multiple units into the mix, you get things like the financial markets. There are multiple shares of Google Inc. There are many people who want to sell and many people who want to buy, and that's a whole different discussion. Yet another topic is collusion in auction. We have so far assumed that all agents are selfish or self-motivated but independent. Well, what happens if two bidders or a set of bidders, a ring, decide to collude in an auction? Can they somehow artificially bring the price down or make it inefficient and so on? And finally, there are auctions in particular domains that have special favors. There have been specialized auctions for the telecommunications market, for the energy markets, for buying and selling electricity, for buying and selling transmission capacity. There are auctions for pollution rights. There are auctions for keywords in ad auctions. And each of those has some very special properties. And overall, a very rich topic that deserves a different, separate discussion.